This is a video on independence of path. The question states, find the value of the line integral over the curve C of f dot dr, where C is the path from the point 2, 3 to 1, 1 to 0, 1 to negative 1, 3. And f is the vector field x squared plus y squared I plus 2xy j. So let's sketch the curve. We start at 2, 3. We move down to 1, 1, and then it moves to 0, 1. Then it moves up to negative 1, 3. I really don't want to parameterize this curve because it would be 3 pieces. Instead, I'm going to check to see if the vector field is conservative. So I find n sub x, and that's the partial derivative of 2xy with respect to x, which is 2y. Then I find m sub y, which is a partial derivative of x squared plus y squared with respect to y, which is also 2y. So because n sub x is equal to m sub y, that means that f is a conservative vector field. And I can say that the line integral over C of f dot dr is the same as the line integral for any curve that starts at the point 2, 3 and ends at the point negative 1, 3. So I'm going to choose the simplest curve, which is just a line segment that starts at 2, 3 and ends at negative 1, 3. And I parameterize that line segment. Notice that x starts at 2, and then it travels to the left 3 units. So x is 2 minus 3t, and y is just always equal to 3 along this curve C1. So r of t is equal to 2 minus 3t, 3. So I also need r prime, so I take the derivative with respect to t, and I get that r prime of t is negative 3, 0. So I can put this together and say that the line integral over C of f dot dr is equal to the integral from 0 to 1. Notice that when t is 0, we're at 2, like we want to be, and when t is 1, we're at negative 1 for x. So t really does go from 0 to 1. Then we have x squared plus y squared. X is 2 minus 3t, y is 3, so I get 2 minus 3t squared plus 3 squared. Then we have 2xy, and that's comma 2 times x, which is 2 minus 3t, times y, which is 3. And I dot that with r prime of t, which is negative 3, 0, then times dt. So I simplified this. One nice thing is we're taking a dot product, and the j component of the second vector is 0, so the second part just goes away. So I just simplify 2 minus 3t squared plus 3 squared and multiply by negative 3. And I cleaned it up, and I got the integral from 0 to 1 of negative 27t squared plus 36t minus 39 dt. This is a pretty simple integral. In fact, the antiderivative is negative 9t cubed plus 18t squared minus 39t. And if I plug in 1 and then subtract plugging in 0, what I got was that the line integral over C of f dot dr is equal to negative 30. And I'm done with the problem.